On May 16, 2026, Shield 16.0, version 1.1 of the specification, was sealed. This was not a maintenance release. It was a major version increment, and that increment was earned. Across the 15.x arc, Shield had been a story of methodological hardening, patching holes, sealing constants, tightening verdicts. With 16.0, the hardening becomes something else: publishable, replicable, and Bayes-readable. The cryptographic spine of 15x is preserved. What changes is the shape of what we can now say to the world. The working title of 16.0 captures it in 5 phrases: publication tier, Bayes factor, replication harness, lexicon sealed, unified export. Each phrase is a pillar. Together they answer a question that 15x could only gesture toward. Can a single experimenter, working alone with a sealed corpus, produce a draw record that a third party, armed with nothing but Python and patience, can verify, reproduce, and weigh? The first pillar is the most invisible and the most load-bearing. It is the Canonical Serialization Contract, set down in Section 7. Before 16.0, the system relied on a permissive stringifier. It accepted ambiguities, composed versus decomposed Unicode, silent acceptance of undefined values, no rejection of infinities. Any one of these ambiguities could allow two identical-looking objects to hash differently, or worse, two different objects to hash the same. The Canonical Serialization Contract closes those doors. NFC normalization for every string. Keys sorted lexicographically. Numbers serialized by the shortest round-trip rule. Undefined rejected. Infinity rejected. Non-finite numbers rejected. 8 test vectors are embedded in the workstation and run at every page load. If one fails, the system goes to a safe disabled state. The Python reference and the JavaScript implementation are byte identical, verified at startup. Every hash in 16.0 stands on this one recipe. The second pillar is the Bayes factor for DT3, the Dominion Triad signal. For the lifetime of 16.0, the priors are pinned. The null hypothesis, that DT3 hits occur at the corpus baseline rate of 0.0144, uses a beta prior with alpha 1.44 and beta 98.56. That is 100 pseudo-observations of empirical anchor. The alternative, that the rate is elevated to roughly 5 times baseline, uses beta with alpha 0.72 and beta 9.28. Only 10 pseudo-observations of strength. The asymmetry is deliberate. The null carries the empirical weight. The alternative stays diffuse, so the Bayes factor is moved by data, not by prior. The Jeffrey scale labels the result: anecdotal, moderate, strong, very strong, decisive. And a sensitivity analysis runs the same draw under priors half as strong and twice as strong. If the Jeffreys label holds across all 3, the method's appendix calls the result robust. If it shifts, the appendix says prior sensitive, interpret with caution. Honesty at the surface. The third pillar is the Registered-Replication Harness. The mathematical object at its center is the design fingerprint. The fingerprint is a single SHA-256 hash over the pre-registered design, the lexicon hash, the Bayes priors, the baseline's hash, the threshold table, and the build hash. If any of those inputs change between draws, the fingerprint changes. And if the fingerprint changes within a series, the series aggregation function throws an error. Hard rule: no silent drift across a replication run. A series carries a planned number of draws, 12 by default, under a fixed-in stopping rule. No early stopping. No peaking. The user interface renders a small power calculator. At 12 draws, the series has roughly 80% power to detect an odds ratio of 3 or larger against the baseline. When the series completes, all draws under one fingerprint, all draws done. The integrity banner adds a replication-grade badge. The fourth pillar is the Unified Export Hub and the H2F bundled JSON file. Until 16.0, exports were a scatter of files. Methods card here, JSON analysis there, methods appendix as a third artifact, replay manifest as a fourth. Now there is one bundle. 12 artifact kinds. Each artifact carries its own content, its MIME type, its generation timestamp, and its SHA-256. Around them, a manifest. And around the manifest, a bundle hash, the canonical SHA-256 of every preceding field. Import the bundle back into the workstation, and it round trips. Tamper with 1 byte of one artifact, and the import returns a structured failure list. Which artifact failed, what was expected, what was found. The bundle is the smallest thing a reviewer needs. Around all 4 pillars sits the Section 11.8 banner, the verdict surface. It has 3 states, not underscore shown before the first draw. Provisional once a draw runs, but the corpus has not been fully verified. Trusted only when 5 integrity dimensions all red-green. Corpus canonicality with full content verification, lexicon binding sealed, canonical serialization ready, runtime hardened by deep freeze, and calibration trust intact. Any blocker observed at any point, blocked, terminal until page reload. The state machine is formal. No verdict drifts upward without earning every dimension. The threat model is documented now, Section 6. Post-draw rewriting of pre-registered criteria, defended by hash commit at lock. Corpus substitution by tampered content, defended by iterating all 34,211 entries on full verification. Post hoc lexicon modification, defended by deep freeze at load and SHA-256 verification at startup. Silent hash drift from Unicode or float ambiguity, defended by canonical serialization. Each row has its defense and a section reference. The residual risks are listed too. Compromise browser runtime before deep freeze runs, single experimenter design, no code signing of the workstation file. None of these are pretended away. What is unusual in the development arc of 16.0 is the review process. Version 1.0 was the synthesis of a 4AI review of 15.3, ChatGPT, Perplexity, Gemini, and Grok. Version 1.1, the current document, synthesizes a second round, this time with ChatGPT, Grok, Gemini, and Qwen. Convergence patterns across the 4 reviewers were tabulated. Where 3 or 4 agreed on a gap, that gap was filled. Gemini stayed an outlier on framework migration, Vue, React, WebGPU, Tailwind. That outlier disposition was declined for the same reason it was declined the first time. The single file model is load-bearing. Framework migration would invalidate every existing hash. What 4 independent models converged on, the spec adopted. What only one recommended at the cost of the spine, the spec declined. Phases 1A, 1B, 2A, 2B, 2C, 3, and 4 are done. Phase 5, the replication harness, is the next milestone. Phase 6 brings the reviewer mode button, the self-test suite, the service worker, the APA-style citation copy. Phase 7 is the final integrity sweep and the version 2 specification freeze. The life force experiment was never going to be settled by a single draw. It was always going to be settled, to the extent any such thing can be settled, by a long record kept under rules that did not move while the record was being kept. Shield 16.0 is what the rules look like when they hold still long enough to be photographed. The cryptographic spine carries the photograph. The 4AI review checks the focus. The bundle is the print in the reviewer's hand. From here, the work is what it always was, to draw, to record, to wait, to weigh. The instrument is now publishable. The witness goes